All right, welcome back to our second video. This video is about the changes of state. So we're going to look at how these states can change from one to the next. And the difference between the state of matter, the solid, liquid, or gas of some substance is really just the amount of energy that the molecules in the matter have. So for example, a solid has low energy. The liquid has more energy than the solid, and the gas has the most energy of all. So here we have a slide that shows water in its different physical states. Here we have ice, that is the solid form of water, and how it can go change to water, the liquid form, and the water can change to vapor or to the gas form. And also we actually can have solid becoming gas or gas becoming solid, and the different names of these processes. So when you have a solid becoming a liquid, that is the melting that's happening. Vice versa, it's the freezing. When you have liquid going to gas, you have evaporation. When gas turns into liquid, it's condensation. When a solid goes from solid to gas, you have what's called sublimation. And a gas to solid is called deposition or deposition. And here and on this slide, it shows the different energy levels, okay? So from solid to liquid needs more energy. A liquid to gas needs more energy. And then we have a fourth state. And this has to do with plasma, which is again breaking something down into its subatomic levels. And that is again more energy. So the energy is increasing in this picture. So something that is solid is in a solid state. Something that is liquid is in liquid state. And something that is gas is in a gas state. And we can increase the energy in each state, therefore increasing the speed that the molecules are moving. And we can do this just by increasing temperature. So a solid, if we increase the temperature enough on a solid, it will actually eventually become a liquid. Here we have another slide just showing the different changes of states. And here we show that a liquid can increase energy enough to become, this one, is the melting point prediction. So it shows how a solid, you have all those molecules and atoms tightly packed together. And as the temperature increases, you get to a point where you have what's called coexistence. So it's starting to melt. And then eventually when the whole solid has melted to form a liquid, you have the liquid state. These state changes happen with that increase in temperature, or alternatively, with a decrease in temperature, a gas can lose energy to become a liquid, and a liquid can lose energy to become a solid. So in this slide, this is showing what happens when a solid like water is melting. When ice is just taken out of the freezer, the temperature of ice is lower than 0 degrees Celsius. As it gains heat from the environment around it, the temperature will rise and it will come to the place, it will reach 0 degrees Celsius, at which point the ice melts to become water. So 0 degrees Celsius is also called the melting point of ice, but the presence of impurities in water will sometimes lower that melting point So you'll begin to see as the ice is warming up, it will eventually reach room temperature, but it will pass that 0 degrees, and at that point it will change from ice into its liquid state. So heat is a form of energy that can be transferred into a solid. And as the temperature goes up, the energy in the solid also increases. And at a certain temperature, the solid melts and becomes a liquid. The temperature that a solid becomes a liquid is known or is called the melting point. And every solid has a melting point. We know that ice water or solid water turns into liquid water at 0 degrees Celsius. Now, something like iron, which is a very, very hard and dense solid metal, melts at a much higher temperature than water. The melting point of iron is 2,795 degrees Fahrenheit. It becomes a very hot liquid with a lot of energy. So here we have a picture of iron that has been melted, and it has a lot of energy. You can see it's glowing with energy. If the temperature of the iron falls below 2,795 degrees Fahrenheit, the iron will become solid again. Aluminum is another metal solid that has a melting point of 1,220 degrees Fahrenheit. If a temperature of a liquid is lowered and heat or energy is removed or taken away, then the molecules want to slow down again, and a liquid will once again become solid. So here we have a slide that shows what the freezing point is, and that's when a liquid turns into a solid. When the temperature is lowered, its particles lose energy and move more slowly. The attractions as they move slowly cause them to turn into a solid. So the temperature at which a liquid becomes a solid or freezes is called the freezing point, or it's also called a solidification point. And what happens to water? We know that water is polarized, and so when water, it acts a little differently than other substances or other liquids. Water freezes at 0 degrees Celsius. It's also the temperature that solid ice water will turn back into liquid water. And so that all those water molecules will slow down until they form a matrix of those water molecules, and that's how they'll freeze. And here we have just another slide that shows the difference between solid, liquid, gas, if you need to come and review this. And here we have lava. So this is molten lava flowing. It's called the lava at Royal Gardens. And so this would be rock, minerals, everything that's melted, and to form molten lava. And that comes out of an active volcano. Lava it becomes lava, this molten lava, it becomes liquid in the temperature range of 700 degrees Celsius to 1200 degrees Celsius. And so what's interesting about this video is you can see that on top you have this solid crust, and yet underneath you have a flowing molten lava. And so you have actually solid and liquid right at the same time and place. And that's because on the top part, it's frozen. It's already reached, it's cooled off enough that has become solid again. And yet underneath, it's so hot that it's still in its liquid form. And so the state of something depends on whether the temperature or the energy is increasing or decreasing. It's so cool. Okay, once again, when more energy in the form of heat is added to already energetic liquid, the molecules will move even faster. If enough heat is added, the liquid molecules will have enough energy to escape into the air as a gas. So here we have a slide that shows a liquid that energy is added to. So when you heat up a liquid and you heat it to a certain point, that liquid will evaporate and will become a gas. It will turn into its gas state. And it will escape into the air around it as a gas. And it will lose that definite shape that defines the liquid form that it was before. So the temperature at which a liquid becomes a gas is called the boiling point. And this is the temperature, again, that the liquid will change into a gas. And the boiling point is dependent also on the pressure that it's under. Here's an interesting fact. The boiling point of water at sea level is 100 degrees Celsius. But on top of Mount Everest, the boiling point of water is 69 degrees Celsius. And this happens because of the difference of pressure between sea level and the top of Mount Everest. So here again, we have that slide of the molten iron, the liquid iron. And it's heated. If this iron could actually be heated, this is just the liquid form. So this is just when it's been, the solid form of iron was heated up enough to become liquid. Now, if you took this liquid to a point where you could actually get it to boil, you would have to heat it up to 4,982 degrees Fahrenheit for it to reach its boiling point. And at that point, this iron would have enough energy to escape and become a gas. But as soon as that boiling iron would fall below 4,982 degrees Fahrenheit, the iron gas would turn back into a liquid. So again, many of these temperatures are sort of theoretical because it would take very, very specialized conditions to be able to reach some of these temperatures. So remember that every substance has a melting point and a boiling point, even if it's just sort of a theoretical. Even something like diamonds. Diamonds are one of the hardest substances known. And they're used to cut just about any material because they're so hard. And that has to do with their molecular structure. They're so stable and they're so strong. In open air, diamonds will melt at about 700 degrees Celsius. But when they get to that temperature, they'll react with oxidation. And so an oxidation reaction will happen. And they'll actually sublimate. This is when the solid will skip the liquid stage and will actually sublimate into CO2. It will just turn back into a gas. That's pretty cool. Okay, so that brings us to the end of our second video. That is all about the different states of matter. Okay, have fun with all the hands-on activities this week and the assignments. If you have any questions, let me know.